Okay, so I'll probably give you a 15-minute lesson or so, and then you'll be doing some work on your own. Okay, 15-20 minutes. So we started talking on Friday about outcome tables and tree diagrams, right? And basically, we concluded, or at least I presented to you, that if you want to know the total possibilities or outcomes, right, you just multiply the amount of choices you have for each event, right? So for example, 2 meals, 3 drinks. So let's say chicken wings and burger, and then you have Sprite, Coke, and ginger ale, right? So you technically have 6 ways of making unique orders. And we demonstrated that visually using a tree diagram. And so, by the way, you could have started with, maybe don't copy this, right? But you could have started this way. This exact same thing, we could have actually started with our 3 drinks. I could have gone drink 1, drink 2, drink 3, and then branched off of each one of them with the 2 meals. Meal 1, meal 2, meal 1, meal 2, right? And so regardless, if you, once you count the tip of the roots, so 1, 2, 3, 4, 5, 6, that's how many options you have with it, and the tree diagram shows you that. The other option to visually demonstrate how many options there are would be to just have an outcome table. So for example, you have your drinks here and your meals there. It could have been, you know, meals here, drinks there, it doesn't matter, you end up with 6 options. Also, by the way, you could have added dessert to this. So meal, drink, and a dessert. So you could have had like 4 dessert options. So every single one of these branches would have had 4 desserts coming off of it. So increasing your possibilities even more. Okay. Let's keep going here. I'm going to make you work on a tree diagram shortly. You're going to have to make your own. So this is what I wanted you to highlight on page 40. All right, guys? Hope you're following. Total outcomes would be, right, options for event number 1, options for event number 2, times options in event number 3, times keeps going, keeps going. You're like, oh my goodness, what is this all about, Mr. Dirksen? I don't get it, right? And this is just what I meant. Like if like the number of desserts you have, number of options for the meal, number of options for the sides, like the more I throw at you, the more different combinations you have, unique ways of making an order. Same with your password, right? Maybe let's talk about example PIN code. Right? You have 4 digits that you may use. Right? So you can use 0 to 9 here, 0 to 9, 0 to 9, 0 to 9. This would be event number 1, event number 2, event number 3, event number 4. Okay. So if you have 0 to 9 for your first code, right, that's 10 times 10 times 10 times 10. What's 10 times 10 times 10 times 10? You just add the zeros. 1, 2, 3, 4 zeros, right? So it'll be 1 followed by passwords or PIN codes. So if somebody wanted to guess your code, there's only 1 correct code out of the 10,000 possibilities, right? But this is how many 10,000 PIN codes possible. So this weird formula that I just gave you, this is one of the applications for it. Okay. If you had a 5-digit PIN code, you would have a 5th event, right? 10 times 10 times 10 times 10 times 10. So it'd be 100,000 options there. Okay. So that's what we're gonna use this for. So let's keep going here. You have two four-sided dice and they're being tossed during a game. How many possible outcomes are there? What is an alternative term for this word that we're just using here for the possible outcomes? So we go this, outcomes would be four options, right? Four sides times four sides. Each, right? This is event, this is die number 1, this is die number 2. So that'd be 4 times 4 would be 16 outcomes. And what do we call this? Sample size, right? Sample space or sample size. The same, basically the same thing. That's the alternative term. If you want to put an arrow to it, there you go. Okay. Fun stuff, eh? Yeah. Hey, at least like down the road, you might take a course in university, college, or might take some kind of, you might actually come across this stuff, right? So how would we make an outcome table? Well, you go, what do I have for my first event? 1, 2, 3, 4, right? This is die number 1, let's say. Those are your options. You list the options. It could have been a die that is colored. A four-sided die that is colored, no numbers. So it could be like blue, yellow, green, red. You put that down here. And then your next one, die number 2, you go 1, give yourself space, okay? 2, 3, don't cram this too much. That's why I made it nice and big there. So die 1, die 2. And what we want here is to list your outcomes. So we would say, instead of meal 1, drink 1, we would just say in this case 1, 1. That's what you can roll here. And then your other option is 1, 2. Put a comma in between. 1, 3, 1, 4. Let's go to the second row. You can roll a 2 and a 1, a 2 and a 2, 2 and a 3, 2 and a 4, so forth. 3, 1, 3, 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3, 4, 4. How many options do we have? 4 times 4, 16. 16 outcomes. You're like, Mr. Erickson, we knew that already. Like, it's right up here. It's just to confirm, right? It should jive. This is without a visual. This is with a visual. Okay, so now that we have this, let's answer some questions. Maybe I will tell you a pattern. You've seen this before. I have a feeling some of you have seen it, but just come with me for a ride here. There's a pattern when you look diagonally at this outcome table like this. For example, this would give you 2. If you were to add 1 and 1, you get 2. If you were to add 2 and 1, you get 3. You also get 3 here, 1 and 2. So this diagonal line gives you a 3, a sum of 3. Let's go one down, 3, 1. That gives you 4. So does 2 and 2. So does 1 and 3. So this is your sum of 4. These combinations would add up to 4. And then 5. And then 6, 7, 8. Right? So that's your pattern. I hope you see it. So let's answer some questions here. State the probability of rolling a sum that is greater than 6. So you want greater than 6. 7, 8, 9, and so forth. So probability of G6. That's what I'm going to call it. Isn't that like a razor or something? 6 blades. Smooth. Anyways, 6 times. So we know already that there's 16 options for that. And I'm going to use a highlighter to find them over here on our table. This diagonal line would give me a sum of exactly 6, correct? 5, 4 and 2 is 6, 3 and 3 is 6, this is 6. So I want bigger than that. So 4 and 3 and 4 is 7, and this is 8. So it's actually this little, these numbers here, if you roll this, you get a sum of greater than 6. So let's call that G6. Okay. So we have how many options? 3 options that apply there. And so let's turn that into a decimal. 0.1875 or 18.75%. It asks for the odds. We'll pause it for now. I just want to do the probability. Let's do orange here. Okay. So this whole thing gave me a sum greater than 6. Which one is here? Which sum is the most likely to happen? Show your work. Show how you know. And I think you would have to agree that it's the one that, like this diagonal line here, has the most options. Like there's 1, 2, 3, 4 options here. If you go up one, if you do this one here, there are only 3 options. If you go one down here, only 3 options. So it's actually this one right here that happens most often. And what's the sum for that diagonal line there? It is 5. That is 5. Like 5 is the sum that happens most often in this case. The sum of 5. So probability of S5. This is S5. I hope that's what you see there. And we still have 16 options, and we have 1, 2, 3, 4 instances where that's the case. That's the same thing as 1 over 4, which is 0.25, which is 25%. I'm going to highlight this in green and just say that this is sum of 6. The green highlighter is a sum of 6. And the last one, in this case, what's the probability of rolling doubles? What are doubles? Right, the same number. And to make this, I'm just going to do this. Those are your doubles. So in this case, I'm just going to call this probability of doubles. Still out of 16, and I have 1, 2, 3, 4. Of those. I need a 1-minute break. So I want you to write this probability here in terms of odds. Like what are the odds of having a rolling a sum greater than 6? And same thing here for E. You want the odds for and the odds against rolling doubles. If you could do that right now, see if you remember from our AC whether or not you did it. Not. Okay, odds for this. odds in favor, so it'd be 3, 2, 16 minus 3, so that'd be 3, 2, 13. Boom. And then odds for and against rolling doubles, 4, oops, that would be 4, 2, 16 minus 4, so that's 4 to 12, reduced to be 1 to 3, and against, you just flip it. Just like that. Okay, so I'm gonna just get you started here. So come with me and I'll assign the pages I want you to do. Let's go to 41. I'll just get you started so that you're not stuck right off the get-go, right? We don't want that. A game consisting of tossing a coin and spinning the spinner as shown here. How many possible outcomes are there for this game? Well, outcomes, you would say, well, what's my first event? The coin toss. So there are 2 options, right? That's for the coin. And then 5 options for the spinner. So 2 times 5, 10 outcomes. So I want you to make an outcome table and a tree diagram showing all the outcomes. So you can use letters. For example, for the colors, use right, G for green. For heads and tails, just use H or T, and so forth. So here's how your tree diagram should look like. You might have to erase. If you're like me, I have to erase almost every time when I start. So I branch off like as far apart this way as I can. You choose. You want to start with the spinner or the coin. I don't really care. But if it's with the coin, you want to go heads, tails, like that. Those are your only 2 choices. So you could land on heads and then land on one of the 5 colors. Right, there's 1, 2, 3, 4, 5. And then you do the same thing here. 1, 2, 3, 4, 5. And I will start with blue, let's say. It really doesn't matter what you start with. So blue, red, purple, yellow, and green. And then you do the same thing here. Blue, red, purple, yellow, green. But we're not done yet. If you look at the example on page 39, at the end of each branch, you actually have to write out what the combination is that you got there. This is literally supposed to, like, if you follow this branch, you get heads and then landing on blue, right? So this would be the combination HB. If you then continue going heads, right, and then it's red. So head, red. Red, head. I should have done it the other way. Anyways. So that's how you do a tree diagram. If you want full marks, at the end of that, at the end of those branches, you want to put down the letters that make up the number of options. And then you do your outcome table. Same thing. You can probably do heads, tails here, or you want to do the colors here. Maybe the colors here is best, and then here would be heads and tails. And you should have every single time 10 options, right? 10 outcomes. And then answer whatever I ask you regarding that. I will post the answer key, and I think you should make significant progress. So you do 41 all the way to, I would say 43, 44. I'm going to say 41 to 44. So write that down here, page 41 to 44, homework. It's actually schoolwork, but if you don't finish stuff here, and I will post the answer key in a couple of minutes. As you're doing this, you can call me for help, Or you can just go on Google Classroom. It's like, I don't want to talk to you, Mr. Dirksen. I just want to go look at the answer. That's fine too. So I'll post it in a bit, and then you just take it from there. But be productive, okay? Use your time wisely.